Stoichiometry, or that point in Gen Chem when most people who didn't really enjoy math tap out. The MCAT is not your general chemistry course. The MCAT is asking you stoichiometry specifically around things that might end up in the human body. Let's say you have a patient who's a child who needs a medication. So you have to calculate on your own how much medication that child should actually be receiving stoichiometrically. Because you can't use your calculator on the MCAT, the way they ask stoichiometry questions tends to be more testing how much you understand manipulating of math. For example, can you convert decimals to fractions? Can you convert fractions to decimals? Do you know metric prefixes? Can you calculate the differences between different exponents? Do you know what a negative exponent means? This is one way in which the MCAT may be asking you, do you know math? But they present it to you as a stoichiometry question. So also being able to round, it's going to be below 100. So all of these answer choices are out, will expedite your ability to eliminate incorrect answers. So you end up having to do a lot less math than you would have otherwise. When white people were institutionalizing science, they were recognizing we needed common terms to be able to talk about things. It was exhausting to say 75 trillion atoms. They wanted to come up with another term similar to how we talk about a dozen things is 12 things. So a dozen eggs is 12 eggs. They came up with a conversion, a mole, to represent a number of atoms. 1 mole is equal to 6.022 times 10 to the 23rd power atoms of whatever you have. In order to be able to answer this question, you are going to have to do stoichiometry, but before you can begin even doing any types of conversions, you first have to set up the equation that represents this chemical reaction. This equation shows you that for every 2 moles of NaOH that are used, you have 1 mole of sulfuric acid that is being used. So there is a 2-to-1 ratio of sodium hydroxide to sulfuric acid, which means that for every 2 moles of sodium hydroxide that are present, 1 mole of sulfuric acid must be added to the reaction for it to be completely balanced. The first thing that I need to ask myself is what's given and what do I need to find? So they tell me that I have 20 milliliters of a 3 molar solution of sulfuric acid. What I need to find, grams NaOH. I want grams to end up in the numerator and everything else is going to cancel out. As mentioned earlier, molarity is equal to the moles of solute over the liters of solution. And so if I know that this is 3 molars, then there is 3 moles H2SO4 in 1 liter of solution. So now I just set this up as a whole bunch of fractions or ratios. There's 20 milliliters, but because molarity is in liters of solution, you want to convert the milliliters to liters. So 20 milliliters times 1 liter over 1,000 milliliters times 3 moles of H2SO4 in 1 liter of solution based on the mole ratio from above. 2 moles of sodium hydroxide for every 1 mole H2SO4. So now I know how many moles of NaOH this is going to be. So then I have to know the molar mass of sodium hydroxide, which I can calculate from the periodic table, and it's 39.997 grams per mole of sodium hydroxide. And what did I need? I needed to find the grams of sodium hydroxide. I have finally gotten 2 grams of sodium hydroxide. So now I just need to make sure that everything else will cancel out. Milliliters will cancel with milliliters. Liters will cancel with liters. The moles of H2SO4 is going to cancel with the moles of H2SO4. And then the moles of NaOH is going to cancel with the moles of NaOH. On the MCAT, you don't get a calculator. So instead of trying to calculate 39.997, I'm just going to call this 40. So now that I've canceled out all of the units, I'm just going to write down what I have left in the fraction on the top and on the bottom. So I've got 20 times 3 times 2 times 40 over 1,000 times 1 times 1 times 1. Multiplying the numerator, 20 times 3 is 60. 60 times 2 is 120. 120 times 40 is 12 times 4 with 2 extra zeros. 12 times 4 is 48. So this is 4,800. 1,000 times 1 times 1 times 1 is just 1,000. I can cancel off 2 of these zeros, and we've got 48 over 10, which is 4.8 grams NaOH. And that would be your solution to the question. If you need to review adding, subtracting, multiplying, and dividing fractions, check the link in the description below.